Please welcome Frank Brilliant and Marisa Kopec from Lux Research.
Lux Research has chosen Metamaterials for our Lux Innovator of the Year award. We are awarding Meta for their 5G innovation. Earlier this year, Meta formed a strategic partnership with Sekisui Chemical, and combining a special 2D metasurface nano-patterned layer provided by Meta and Sekisui's film processing technology, they created a new product that is durable and transparent, yet diffusely reflects only radio waves, eliminating blind spots in communication. It's super cool.
On behalf of everyone here at Lux, I'd like to congratulate the team at Metamaterials, who demonstrated breakthrough innovation thinking and best practices. Here to accept the award on behalf of Metamaterials and presenting their award-winning use case is George Palikaras, President and CEO. Congratulations.
Frank, Marisa, thank you very much. At Meta, we are extremely honored and excited to be accepting this award, which not only combines 5G communications, which is the future, but also has a sustainability element, which we are very, very proud of. In the next few slides, I'm going to demonstrate how our solution works and why it has the promise to help enable dense urban environments sustainably. So before we go on to the solution, I would like to just very briefly introduce Metamaterials Inc. Meta publicly listed on the NASDAQ earlier this year. Our market capitalization is just over 1.4 billion. And with the work that we have done over the last 10 years, we worked on the cutting edge of metamaterials, where it intersects industrial applications with a great promise in terms of how we use this technology and how we innovate in this technology. One of the key things about metamaterials is the fact that they're very scalable, and they have only been recently created at low cost, kilometer lengths with roll-to-roll processes. Meta has been active in this field in the last 10 years. And not only we have come up with new innovations, like the one that we have received an exciting award today, but in areas in aerospace where we have promising applications, medical, automotive, as well as consumer electronics. Here's a couple of the topics that we'll cover today, starting with why 5G deployment in the city areas has both a promising future, but also some technical challenges that we are trying to solve. We'll go through some of our Meta sustainability development goals, and we're going to talk about how AI software, what we call material informatics, has been able to help us design fast, as well as innovate in areas that traditionally normal materials would not have such high success. We're going to go over the Meta technology platform, broadly speaking, how else we are applying some of our smart materials at scale, and then close off with the promise of metamaterials, which is doing more with less. To start off, what you see in this slide is our innovation. One of the challenges and opportunities in 5G, which is, according to analysts, a $2 trillion infrastructure project that is rolling out across the world, with about half, about 1 trillion being spent in Asia, is the fact that infrastructure today needs a lot of planning. Think about regulatory processes. Think about city planning, permits, and also wires and power being delivered at each location. Now, if you think about this image on the top here, what you see is a base station antenna that's mounted on the top of a roof. And throughout 3G and 4G, windows and buildings could reflect and create hotspots down below. At 5G, especially the millimeter wave bands at 27, 28 gigahertz, this is no longer the case. Everything around us, especially things that have water contact, including trees and people, absorb the energy, therefore creating very spotty reception, black spots. So at Meta, we figured that there must be a better way than having repeaters all over a city center or dense populated areas. And when I say repeaters, I'm talking about repeaters that would be placed 20 to 50 meters apart. So you can imagine something like Wall Street or a dense city like Tokyo or Singapore. The effects that having such and so many repeaters, not only in infrastructure but in aesthetics, would alter how a street looks like. At Meta, we designed and developed a solution for this problem. With the very few, up to 10 times less repeaters, so having far less power needs, we have devised a transparent film that can be placed on any flat surface, also on lampposts. You can wrap them in our material, a material that is smart, that reflects in different kinds of ways, passively, 100% with no power, the 5G and later on the 6G signals. We worked with Lux research team that helped us divide and conquer in terms of strategy, basically to define our product spec and our approach to the market. And we are very proud to have partnered with Sekisui Chemical in Japan, whose partner Docomo has been working with them to deploy our solution and test it in very large, densely populated cities like Tokyo. The impact here is, how do you transmit 5G sustainably, without power, without the hassle of getting a solution registered, without having the regulatory hurdles and planning permissions, and the ability to basically install a solution anywhere that the city planners wish that to go to, with the added benefit that building developers can actually generate revenue from the surface of their windows. In addition, one hidden benefit here is concerning with people who are RF sensitive. There is a growing population that does not want 5G inside their homes or their offices. Our film does not only passively reflect, but it can passively transmit the waves through the glass. So if you're looking to have 5G in the home, we can provide that capability. But if you are looking to totally protect, block every single signal that goes into the home, especially in 5G and 6G applications, we have that solution too. So moving on to this slide, where we talk a little bit about more of our sustainability development goals. 2020 has been a decade of action for SDG. Meta has identified 6 important strategies, which link to 17 goals. And within those, we are looking at 5 megatrends, which include climate, the circular economy, ethics, health and equity, and development. When we started working in this, we had a big advantage. Meta had invented a process called rolling mask lithography, RML for short, which has been proven to use orders of magnitude less energy per square meter produced compared to other semiconductor processes. So that armed us as a big advantage to what came later. Our product NanoWeb, which we developed, combined with a Sekisui Chemical partnership, who developed a special substrate layer for us. This became an alternative to printed circuit boards and PV that basically allows us to have 100% recyclable material. Meta has been announced in 2019 as one of the global top 100 cleantech companies. So let's look in more detail how NanoWeb works. So for 5G, what you see here in the circular image is a hand holding up our film against the blue sky in California. And you can barely see the edge of our circular film. This is because our film is 99% transparent. But what it does, it can reflect radio waves, and multiple reflection modes can be accomplished, as you see in the bottom images. So you can have 45 degrees equal spread, you can have concentrated spread, you can have off-angle spread, or even multiple angles of spread. And this is one example simulation of how some of these waves get reflected towards a desirable direction. Now, what does that all mean? NanoWeb can be used as a transparent conductor into antennas and reflectors, EMI shielding, de-icing and defogging, and optimized designs. All of this can be achieved in one layer or multiple layers of our product. It can be added on things like windows of cars and buildings, as well as headlights and eyewear. What that means is that NanoWeb is a platform technology that is very versatile, and it only costs reasonable amounts of money. We are happy under NDA to discuss with potential customers and partners what that means for future applications. We are currently scaling our production. Meta has been investing about $10 million since the beginning of the year, and we have a target to reach more than 1 million meters square of production before the end of this year. Our roadmap says that we will be at 15 million meters square by the end of next year, and we're looking to develop partnerships because we are a business-to-business company, and we work with the raw material suppliers and the OEMs to create innovations that have breakthrough performance. Our record to date is a 40x improvement to what was there previously. So as some key takeaways in summary, metamaterials have been designed to do more with less. More means more performance, less material. Our typical thicknesses on our designs are about 1/10 of what a normal coating would be. And because our AI software approach, we are very fast to design and deploy them while using very little, if any, energy consumption, especially in the case of 5G. Number 2 is that Meta is pioneering commercial production at scale. Meta started as a technology company, but we are now scaling our industrial processes and our proprietary roll-to-roll manufacturing to offer successive generations and drive cost reduction. And finally, our platform technology scales repeatably across multiple verticals, whether it's automotive, aerospace, healthcare, energy, communications, or consumer electronics. We have a smart material that can help take a product to the next generation performance. Just want to say a big thank you to the organizers at Lux. And if anybody is interested in contacting us, please do so through our website, metamaterial.com. Thank you very much.
Thank you, George.